Well, good evening, everyone. My name is Anthony Luscre, K-A-Z-T, and this presentation was also written by Marty Wohl, N6VI. Marty was unable to be with us here tonight live, but he has provided a lot of the materials for tonight's session. Tonight's session is the second in our new series called First Steps in Amateur Radio Communications Prep. The first session was on VHF, UHF, and you can find that operations on the RATPAC website or search for us on YouTube. So tonight we're going to talk about the other thing you need to make VHF, UHF contacts, and that is antennas. My contact information and Marty's contact information. By the way, we will make sure that all these materials get posted to the website. But in the meantime, this is the link to get to the slideshow presentation. This will also give you access to all of the links that are embedded in the presentation. They'll either be in this font or have this symbol with them. You can also scan the QR code. I'll have that at the end also. That'll get you access to the slideshow. We're going to focus tonight mainly on 2 meters and 70 centimeters, but what we're going to talk about tonight applies to all of the VHF and UHF bands. So we talked about the various components last time, and tonight we're going to focus on the antenna aspect of those components in a station. A good antenna system benefits any radio. It's the most important link to the outside radio world, and a good antenna system improves both transmitting and receiving. An amplifier can help your transmit signal, but it can't do anything for your receive signal for the most part. So antennas are very, very important. I have the first link here. This is a link to an outside document that I showed last time that has a number of antenna resources on it, and I'll be going back to that a little bit later. But let's start from the beginning and sort of work our way through. Although the HT's rubber duck may work on your radio, there's a lot of ways to increase your signal. And we mentioned this last time, things like adding a tiger tail as a counterpoise and some other things. So we're going to dig deeper into those this week. And there's a number of options available for VHF, UHF antennas. Part of the thing that's going to determine what type of antenna you're going to use is that you have what type of operation you're going to do, whether it's portable, mobile, or base, what type of antenna you want. So first of all, most of us end up with our first amateur radio antenna attached to our HT, and that's referred to as a rubber duck. It's actually a helically round metal coil covered by a polymer substance such as rubber, plastic, etc. Unfortunately, it's the least efficient antenna, and it can handle the minimum amount of power. There's some things we can do to improve on that as far as still keeping an integrated antenna. An integrated antenna is one that attaches directly to our radio or is suitable for attaching directly to our radio. The first example is a standard rubber duck. Here's an extended rubber duck. The next one, number 3, is an extendable metal expansion antenna, telescopic. Here's the tiger tail we talked about last week. This simply adds about a 17 to 19 inch wire to your 2 meter radio to act as an additional counterpoise. You can also get extended whip antennas that fold up. They're called tactical whips. Or you might even take your existing whip, no matter which one it is, and mount it outside the window of your car if you're operating in the car, and then attach this to your HT. So here's some antenna choices for a handheld. The rubber duck, of course, comes with it. The problem is it's the worst antenna you could basically have. The good thing about it is it's flexible, resistant to breakage, and it usually comes with the radio without any additional cost. An extended length rubber duck is very similar, but the extended length means that it has better performance. The downside to it is, though, it's hard to move around with a 19 or 20 inch whip sticking out of your belt. You get caught on things as you walk by. You also have to be careful you don't poke people in the eyes. The same thing with the number 3, the extendable whip. It uses sliding metal, so it's even a little more dangerous as far as getting poked in the eye with than the extended rubber duck. But again, you'll get better signal. Same thing with the foldable tactical. Now, stubby ducks are even shorter versions of the rubber duck, and they're even worse. So I guess the rubber duck isn't the worst antenna. A shortened rubber duck is even worse than a regular rubber duck. The rat tail is simply a wire counterpoise. It goes along with your rubber duck or any of these other antennas to increase the performance by using a counterpoise. It's very easy. You can try it out. It does boost your signal, and it only costs a few cents. It's basically a wire that's attached to the ground part of your radio. This internal duck mounting would get the duck out of your car and greatly improve your signal. Unfortunately, aftermarket replacements are only marginally better. So what's the answer? It's typically a separate external antenna as opposed to that integrated duck or whip. Now, number two, while you're thinking about a separate antenna, you may also want to consider upgrading from that HT to a mobile or base radio. Again, both of these two things will give you a much better signal on VHF, UHF than a simple HT and rubber duck. One thing that's very important on VHF and UHF is getting your antenna as high as possible and in the clear. And with a base antenna installation or some of our mobile or portable antenna installations, we're going to be doing this. Some external antenna options include mobile antennas, portable antennas, base antennas. You have two main options, building your own or buying a commercial antenna. We'll talk more about that at the end. So here's some mobile antenna options. Our first one is a magnetic mount vertical. Here's another one that's a little bit longer, a little more gain. Would screw on to whatever type of mount you want to use. This is called a comp antenna. We'll talk more about that later. Here's an on-glass antenna where we actually send the signal through the glass. Here's one of a type of halo antenna. This is used for horizontally polarized signals. Here's another type right here. So again, we have our little chart. The first ones we talked about, the verticals, they're metal. They may have loading coils, they may not. They may have capacitance hats, they may not. They may be multiple sections, they may be single sections. There's different lengths though. And those lengths are based on wavelength. So you have quarter wavelength, half wavelength, and 5/8 wavelength. Each has its own characteristics. The signal radiated from a quarter wave antenna is directed at higher angles. Remember again, when the angles go up, that means your signal is not going out on a horizontal, which you want it to get to other stations. So some of the signal is lost when it goes straight up. The 5/8 antenna directs much more signal towards the horizon, and it's ideal for flat terrain where signal coverage is sparse. Half-wave antennas are utilized when there is a poor or non-existent ground, such as vehicles with bodies made of fiberglass or composite materials. So they have not only different characteristics as far as their pattern, but also in how well they work with the counterpoise that they're on the vehicle. The compact antenna is a proprietary technology. It's a spiral cylindrical metal sheeting. It's very short, stout form factor. Unfortunately, it has less gain, but it's less likely to strike the roof of your garage as you pull in. A halo antenna is used for one thing specifically, and that is to get horizontal polarization. Now, I need to make sure that we're clear about this. When I talk about horizontal polarization, I'm talking about the way the signal is polarized. And when I talk about horizontal concentration of signals, I'm talking about the area in which we direct the signal. With a vertical antenna, we tend to think of it as everything going out in all directions, but by lengthening the antenna, changing certain characteristics, it can make more of the signal come out horizontally as oriented towards the antenna. But that's not what I'm referring to here. I'm talking about this is a vertically polarized antenna. This is a horizontally polarized antenna. Horizontally polarized antennas are typically used for single sideband and digital work on VHF and UHF, whereas FM work typically uses vertically polarized antennas. If two stations have different types of antennas when they're communicating directly through line of sight, which is the case with most of our VHF and UHF, you will have less signal strength between the two. So you want both of them to be the same, whether it's vertical or horizontal. If both antennas are polarized in the same fashion, you will have a better connection between the two stations. Doesn't mean you can't make contacts, but it will improve. Now, with a mobile antenna, we have a lot of choices as to where we want to mount the antenna. We could mount the antenna on the roof. We could mount it on a on a bracket on top of the car, such as a roof rack. We could have a gutter mounted antenna. We could have a fender mounted antenna. We can have a bumper mounted antenna, a lip or trunk antenna. These are all different types of mounting locations. We can choose different types of mounts to mount them at each of these. So example, we have a magnetic base on the top of the car, whereas we're going to use a lip mount here on the trunk lid. Here's what some of them look like. These first three on this far left side are all mag mounts, but notice they have different connectors for the antenna to attach to them. So we're talking about two different things here. The way we mount the antenna and then the way the antenna attaches to the mount. This is an NMO connector, this is a PL259, and this is a 3/8 inch, which we'll talk about a little bit more later. Here, this one and this one down here, we have two examples of lip mount antennas. These can be used on gutters, they can be used on trunk lids, hatchback lids. Notice that part of it folds underneath and connects to that lip, usually with set screws from the bottom that go up into this. Notice also that these have adjustments for both angles, so we can turn them at different angles, we can tilt them, we can adjust them so that it matches the angle of the car and make sure the antenna is vertical at a 90-degree angle. This is an example of a mount that would attach inside of a door jamb, inside of a fender, inside of a tailgate on a truck. So again, an area where it's flat, and this will fit in between that area, and we mount it there. We have a mount here using a towing hitch. Here's a mount that fits behind the license plate. It's actually a license plate holder and an antenna mount. And some mounts and some antennas, it sometimes can be the mount, it sometimes can be the antenna itself, have the ability to tilt over, so you can easily leave them on the car, tilt them over, and bring them into a low-hanging garage. This can be done in a couple different ways. You have automated ones where the system tilts it up automatically using a remote control in the car. Others you pull up, it releases a holding spring, and then you can tilt it over. Others have twist-off bayonet type connections, which I'll show you a little bit more on a later slide. If you want to operate mobile, you don't always have to have, if you want to be able to operate only when you're stationary, you don't need to necessarily have the same kind of mount if you want to operate mobile. So in this case, all of these will let you drive the vehicle. Some of these, for example, a drive-on mast holder or a tow hitch mast holder, or this additional tow hitch mast holder here, all of these would let you operate only if you're stationary. But the big advantage is you can use a mast pipe and get it 20, 15, 30 feet in the air. So you can get a tremendous amount of additional height. Of course, you lose the mobility factor, but they're easy and quick to set up. This particular one could be left attached to the car. You simply drop the mast pipe through there, have a base at the bottom of it. This one tilts over so that you can, it rotates towards us or away from us, and will let us put the mast pipe in there, then put it back up. This one you drive onto. So let's look at some of the different antenna mounting options that are available. The first one is probably the most common, and that is a magnetic mount, antenna mount. These are very easy to swap between vehicles. They're very quick and easy to put on. There's no screwing or anything like that. You simply put it on the vehicle. One of the biggest problems with some vehicles are they may not have metal in the area that you want to attach it to. And sometimes there may be metal, but the metal may be so thin that the mount wobbles or makes the metal move up and down. So you have to be careful about that. But they are probably one of the most common. One of the cons is they may damage the finish. There's a number of things you can put underneath them. Some are effective, some are not. The other con is if you get an insufficient amount of magnetic attachment to the vehicle, these are a danger for flying off at high speeds, especially if the antenna is too large. So you have to make sure that you're matching the mount to the antenna size. So with a larger antenna, you might need like this triple base one here, whereas this very small one would work with a smaller antenna, but not a much larger antenna. Through roof antennas are probably the best performance, and through roof means you basically punching a hole through the metal of the roof. Something can be very intimidating. I've only ever done it on one vehicle. It did work out. It wasn't a problem even when I resold the vehicle, but it can be a problem for resale value. If you're thinking about a through roof connection, don't just take a hole saw from the local hardware store and go out there and do it, because I guarantee you'll end up with a non-round hole. You'll end up with an ovoid hole. And also there's a lot of danger when you're drilling into the roof of hitting electronics that might be in the roof. You may also hit airbags, sensors. You may hit other things. So I would suggest, if you're planning on a through roof installation, best done by professionals. Find a professional mobile radio installation facility to do it for you. The next four, fender, trunk lip, bumper mount, door jamb, are all those metal brackets that we showed you will fit around various parts of metal, have adjustments to make the antenna be vertical. You can use larger antennas than you can with mag mounts, but you still need to be within reason. The mount has to be sufficiently robust and the connection has to be sufficiently robust. Nothing worse than attaching it to the trunk lip and then the antenna is so large that it actually bends the trunk lip. Not something you're going to make a lot of friends with, of the other family members. Some of the cons, quite often these are not the highest point on the vehicle. Bumper mounts especially with shorter antennas. There are two solutions to that. You can use an extension shaft that brings the antenna up higher, or use a much longer antenna. These type of mounts are very dependent on the specific vehicle. So if you're thinking about one of these, take a look through some of the mailing lists and see what other people with the same exact model and year of car you have are using, or just go to some place like the Dayton Hamvention, walk around the parking lot and see what type of mounts worked on what type of vehicles, and then if the driver's there, ask them, how does that been working for you? Number 7 is the glass mount. This is probably the easiest way to get access to the interior, because on all the other ones you have to still run the coax into the vehicle. Only the through roof brings it directly into the vehicle, but you have to punch a hole in the roof. The glass mount has two parts to it. One part is the antenna with adhesive that sticks on the outside, and then there is the unit that attaches to the coax and sends the signal to the antenna. Cons of these: the adhesive can fail. I've had them on my car. It's worked okay, and then it flew off on the freeway, never to be found again. Or sometimes the adhesive will start getting weak and you'll try and remount it, and sometimes it works, sometimes it doesn't. These are only good with very small antennas that have very little wind resistance. One of the problems, as you'll see, this type of antenna has fairly poor performance compared to almost everything else. A roof rack will allow you to avoid damage to your paint, gives you good height above the car. Sometimes there's poor grounding the roof racks though, so you might need to run additional grounding materials such as straps between the roof mount, the antenna mount on the roof rack down to the actual body, and make a good electrical connection for a ground. The ground on the magnet mount is actually from the inductance between the mount and the metal. So when you start getting above that, like with a roof rack, you might need extra grounding. License plate holders can work on a variety of vehicles. One of the problems is for VHF, UHF, they're very low on the vehicle in most cases. On some vehicles they might be a little higher, but that can be very problematic. They're often used for smaller HF antennas and not for VHFs. Things like small screwdriver antennas can be mounted on the license plate holders. A tilt-up mount allows the vehicle to enter parking decks, garages, etc. They can be more complicated and expensive, especially the automated ones that you operate from inside, and they are not designed for larger antennas. You have to make sure that you're not exceeding the strength of the device. Towing hitch can support large antennas. You can also use it to support stationary support masts. It requires a towing hitch on the car. It's low in the vehicle. It may interfere with opening the trunk, so a lot of people get extended lengths that will not interfere with the trunk or rear hatch opening on the vehicle. They're great for portable operations though, especially if you're using a mast to get a mast up in the air. A drive-on mount, very similar to the towing hitch, but you can use it with any vehicle. It doesn't have to have a towing hitch mounted in it. It may require guying of taller mast for stability. And you also need to be careful because they can damage the surface that you drive them on. So you want to be careful with asphalt and other soft materials. They're great for portable operations, again, higher gain beams, multiple antennas, etc. Now, I mentioned earlier that all those mounts have a connection to the antenna, and here's a close-up of those. The first one is an NMO. We have two types, a NMO designed for a standard mount on a Magnum mount or one of these, or a lip mount, or a bulkhead one which might be used on a through-the-roof mount. Here's another, number two are examples of 3/8 24. So the 3/8 inch 24 thread pattern, and they can either be the antenna screws into the holder, or you might have a shaft that sticks up that the antenna screws onto. Either way, but the commonality is they use 3/8 inch 24. Now there are some out there that do use threaded rods, but they are not 3/8 24 pitch. So make sure that you know what it is before you do that. Now, one of the things you can do is you can screw something like this in, number 3 here, or both of these are examples. You screw this in, then you screw the antenna into that, and it's a quick release. So you don't have to disconnect this, you don't have to take the antenna out of it. You can quickly release it with a bayonet type of release. Hustler has a little different one. The bayonet actually hooks inside, but again, you push down on this and then you twist it and take it off. Number 4 shows a PL259, just actually an SO239, similar to what we have on the back of our radios. A lot of Japanese antennas use this style. Yaesu's ATS 100 antenna used this style. The antenna was designed to match the 857. Here it's on a lip mount, but it can be on any type of mount. Here's a mag mount, but the thing I want to point out here is it has a BNC connector. These were very popular in the olden days when most HTs had BNC connectors on them. You could put this on the roof, put your BNC rubber duck on top of there, and get better performance than when it was on the radio itself. This can also be useful if you want to run external antennas. You can leave this mount in place after you take it off, or this mount in place after you take the antenna off of it, and screw on coax to an external antenna that you're running up that mast pole that you had. That way you don't have to bring the antenna coax into the car. You have a ready way to get it in. Here's an example of the glass mount antenna with the adhesive on both pieces. This is the part that goes in the car, this is the part on the outside. Here is an N-type connector on a mount. SMA connectors, there's 4 types. There's SMA, male and female, and then there's reverse polarity SMAs, both male and female. These are very popular on HTs nowadays. And the problem is they're hard to tell which one you have. So if you're buying an adapter for your particular HT or your antenna, make sure you're getting the right one. This is an example of a all-in-one. This doesn't come apart. The coax is attached, the antenna runs up right from here through this spring, so it's an integrated, everything is all in one. It's not really a mount for an antenna, it's the antenna with the mount built in. And these are all the ones I just listed. If you're interested in going mobile, I suggest taking a look at 3 websites. The K0BG, also known as the Mobile Bible, he has just tons of stuff on his website. Again, when you click on those links, you go out to it, and you can see he just has tons of stuff on mobile, both HF and VHF, on things such as grounding, bonding your metal together, etc., etc. The Going Mobile series from Ham Radio School has 2 parts to it. This is by K0NR, I'm sorry, W0STU, Stu. Bob is the other person that writes for them. I had some stuff from Bob last week. And he has 2 whole things here on Going Mobile, talking about antennas, electrical, installing the radio, etc. Lots of very good information. There's 2 links. It's a 2-part series. And then this one's just a short one from KV5R on relative locations on the vehicle for antenna installations. And there's been a lot of people that added thoughts to this. It's rather short to begin with, but then a lot of information has been added. Our next type of antenna is a base antenna. Now, just because it's a base antenna doesn't mean you have to use it with a base radio. You could hook your radio up on your base station. It could be a mobile radio. It could even be an HT connected on the end of the coax. But these are all antennas that are designed for stationary mounting, typically on a home, but they can also, in some cases, be put on a mast and used in portable operations. So we have here what I'm going to refer to as a fiberglass VHF, UHF base antenna. The antenna itself is not fiberglass. The antenna is inside of the fiberglass. It's metal. It can be multiple elements. These can be in multiple heights. They can be single piece. They can screw together. I'll show you some more examples in a few minutes. Another very popular vertical antenna is one made out of all of aluminum. This is known as the Ringo Ranger or Ringo Ranger style antenna. There's two different types. One has an extra little part at the bottom, so it's a Ringo Plus. But these are very popular on 10 meters through 440. Number 4 is an example of a Yagi. Number 5 is a quad. Number 6 is a log periodic. And number 8 is a disc cone. And here's some of our pros and cons on those. The vertical metal or fiberglass covered is omnidirectional, very easy to mount, very effective. These are probably a very good idea if you're looking for a base station. This would be my first suggestion. They're omnidirectional. Typically, the longer they are, the more gain they have in the horizontal pattern. So bigger is better in that case. But you don't want to get too ridiculously big. Ground plane antennas are simply a vertical with counterpoises sticking out of it. They're very easy to DIY, to build your own. We'll talk more about those later. Same thing with J-poles. They're made out of copper, pipe, aluminum, or wire, and they're very easy to DIY. You can also build portable versions, which we'll talk about more. The Yagi is typically aluminum, but DIY versions may use other materials. My first antenna that I built was a 2x2 piece of wood as a long mast with aluminum fence wire straightened out and used as elements in it, and a copper piece of small pipe used as the main feeding item. It's from the Bill Orr's series book on build your own antenna beams, and it was very interesting. So typically aluminum, but they can be made out of things. Cubic quads typically are made out of wire and spreaders, high gain and directivity, but they're a little more ungainly and difficult to mount than your typical Yagi, which is pretty easy to mount. In any of these antennas that are directive, you need to use a rotor if you want to have them go in different directions. If you only want it in fixed direction, that's fine, but otherwise you're going to need a rotor to be able to rotate it. And in my case, my first Yagi that I had, that wooden mast one, was in the second story of my apartment, attached to the ceiling with a fishing line swivel that I could spin it around. I had 2 plastic drinking straws on either end to keep it from tipping, and so it would stop at a specific point on the ceiling. The log periodic typically has a very wide frequency coverage. So something like this may cover 2 meters to 440 or even up to 1.2 gigahertz, depending on what it's set up for. A dipole can still be used on VHF and UHF. It might be made out of wire like a traditional HF dipole, but typically on VHF and UHF, they're made out of solid metal, either aluminum or brass or copper, because they're quite a bit shorter and lighter than you would with the regular dipole, and you can actually rotate them also very easily. Cheap, easy to make. It may require 2 supports if you use wire, but if you're using metal, you can get away with 1 port. They do have a lower gain than a lot of these other antennas, and they can also be arranged vertically, so you can have a vertical dipole with the elements sticking up and down. They don't have to be horizontal. A disc cone is typically made out of metal. Sometimes it's made out of rods, sometimes it's made out of plates, sometimes it's made out of a combination of the two. They have very wide frequency coverage. They're omnidirectional. They have typically lower gain, somewhat complicated structure, but they're used quite a bit for receive antennas because of their wide frequency range. You can use them on multiple bands very easily. Again, this is what I'm talking about right here. So I mentioned more length, more gain. Here's an example of 3 antennas from the same manufacturer. I'm not sure if these are Comet or if they're Diamond or another competing brand, but you notice each of these is slightly longer, and we go from lowest gain, a little bit more, and the most gain. Notice this is actually 3 pieces, and this is quite long. This is probably about 3 to 5 feet, probably talking about 6 to 9 here, maybe up to 12 here, and maybe 15 foot here. Not only the gain happens because you get more signal directed in this pattern off towards the horizontal, towards other stations, even though this is a vertically polarized antenna, and less off the top. So here's an example of a vertical antenna and the fact that it does have gain in the directions we want it to. Same thing with a horizontal antenna. So you don't have to have a beam to have gain. Now, when we start talking about beams for additional gain, we also get directivity with these. There is no free lunch, so you get your gain by only sending signals into a limited number of directions. Single band Yagis, multi-band Yagis, circularly polarized Yagis, which you use typically for satellites, cubical quads, log periodics. By the way, those tend to resemble broadcast antennas, and one of the nice things about a broadcast antenna appearance is, as we'll see later, that means that you can get away with using them when there's antenna restrictions. Quaggies are sort of a combination quad Yagi that are used on some VHF and UHF. If we're talking about portable antenna operations, we can choose some of the same antennas we're using for our base operations, both beams and verticals, but then we can also choose things such as a J-pole that's flexible that we can roll up and put in our pocket. Configuration can be altered for vertical versus horizontal propagation, and also we can figure out a lot of additional mounting methods to use them in a portable situation. So the first 3 we're talking about here are all examples of antennas you could roll up and put in your pocket. They are made from twin lead line. The first one is an example of a 450 ohm ladder line J-pole for 2 meters and 440. You can see that it's about 53 inches total length. About 57 inches total length, and parts of it are clipped off, and we can hang this up from a support in a tree, just flipping a rope over a branch inside a building by lifting it up, pulling it up. Here's another one made with 450 ohm antenna feed line. This is a 2 meter Slim Jim, it's referred to. Very simple construction with a 1-inch gap, and we feed the antenna at the base. Here's the G1 SLP dual band 2 meter 70 centimeter J-pole using 300 ohm ladder line. There's also portable Yagis. These the Arrow 2 backpack portable. These elements in purple all unscrew, and the mast actually unscrews into 3 pieces. So this is very short, probably about less than 2 feet. You can easily put it in a backpack and carry it. Very lightweight. These are called arrow antennas because they're made from aluminum shafts, very similar to what are used for arrows. Here's another one that's very easy and flexible. This uses the yellow portion are actually sections of tape measure on a PVC mast. This is used quite often by people doing fox hunting, but it works great for directivity and very simple and very inexpensive to build your own. One of the things about portable operations are we're going to have to put up something to support the antenna. Now, we could erect towers if we're doing a major operation like we might do for field day, or maybe a push-up metal mast or a fiberglass mast. There's a number of extendable ones that are available that are stout enough to hold up a small VHF, UHF beam because they're much lighter than would be a corresponding HF beam. You might also use an extendable flagpole, and that's what I have that I use, and I'll show you that in a few minutes here. Painter poles work very well. Again, painter poles are a great way to carry around a portable small Yagi in the field and get a great signal. So think about the difference between that rubber duck on your HT that you're holding in your hand as opposed to having a small little beam at about 18 feet in the air that you can walk around like a walking stick and easily point in any direction and get gain. Arborist poles also work. Tripods are useful for supporting some of these things, these masts, or you can mount them. Sometimes you can bungee cord them to whatever is there, whatever is handy. Wooden decks, trellises, whatever you might be able to get use of. Sometimes you can simply hang a rope from a tree branch or an overhead structure, drop it down, pull up a J-pole, and work very well that way. If you're operating portable from a vehicle, that drive-on mast support or that one that fits into the tow hitch is a great way to go. Having a small Yagi, either commercial or DIY, or one of the VHF, UHF fiberglass base stations on the top of it, will give you a fabulous signal with very little effort using your mobile radio and a small mast. You need to run coax between the rig and the radio. Keep it as short as possible. One way to do that is to simply feed it through the mag mount that doesn't have the antenna attached on the outside of your car, and you can close up the windows and operate in inclement weather. Here's an example of a simple possible setup. Here we buy one base drive-on unit. We pick up one of these 48-inch fiberglass masts, and I'll show you what we're going to use that for in a minute. These, by the way, are not really masts. They're designed to hold up camouflage, but you can find them as Army surplus quote-unquote mast at almost every hamfest. I want you to get one of the fiberglass ones, though not one of the aluminum ones. You only need one for this particular operation. Then you go to your local Harbor Freight and you buy the 20-foot telescopic flagpole. Here's what it looks like. An interesting thing is this ball on the top unscrews. The top of this mast fits perfectly into that. So it gives you 24 foot, and the top 4 feet will be non-conductive fiberglass as opposed to the metal in the flagpole. You can then screw mount your beam on here, or I'm going to suggest in this case just a simple VHF vertical fiberglass antenna screws perfectly onto there. You drive your car into the mount, you put your base of your flagpole on here, you put the fiberglass on the top of it, and then you push this up one section at a time, starting with the top sections going up, and you twist them and it holds it in place. That's what I did last year for field day. That's what I also did for our local VHF UHF contest. It worked very well, and these tend to go on sale in the spring. I got mine for $40 last year. I think they're currently $89 retail, but there's always coupons and sales going on. Some satellite options. If you want to operate satellites, either portable or at home, VHF, UHF, you're probably going to want two bands coverage, at least 2 meter and 440. Here's an example, the ARRL antenna, very similar to that one we saw earlier. Again, it uses those ARRL shafts. This one has 2 meters going horizontally here, 440 going vertically, a handle to hold it on, and there's a diplexer in the end. You can connect this to your HT or to your mobile radio. You hold it, you can also twist it and get the best signal and point it towards the satellite. Here's one from Elk Antennas. Here, instead of having them on this type of beam, it's integrated into this. Here's a do-it-yourself using wood and some wire and some bunch of things for do-it-yourself. Here's one for much higher gain. This is circularly polarized. This is what I used for Oscar 10 many years ago. I have a 2 meter version and a 440 version on a single shaft. This particular rotator does both azimuth and elevation, so you can tilt it up and spin it around. If you want something that doesn't move, this is an omnidirectional egg beater antenna. This is a commercial version, but there are DIY yourself ones. So again, the ARRL, the Elk, the egg beater. I don't have a picture of the homebrew egg beater, but I have a link to it so you can go out. And this is the homebrew egg beater. You need to make one for each band you want. The $4 DIY antenna. Unfortunately, the website is missing now, but fortunately, Dave did a video of building one, so you have Dave's video you can watch on how to build it. And then as soon as the $4 DIY satellite antenna came out, there were mods that came out to improve it. So here's some mods on how to improve it and make it better. And here's the circularly polarized beam. This is the WA5 JB beams. He has a whole series here. This is the one for satellites, but he also has other beams he makes on these wooden masts. Very simple. The wood masts work out very well. These are portable antennas. You don't need to worry about, the wood getting wet or anything like that, but you could seal it if you were going to have it in bad conditions. You can save money on VHF, UHF antennas by building them yourself. They are smaller, simpler. It's great to experiment on these compared to HF antennas. A VHF beam is so much smaller and easier to build than a HF beam. It's a great place to try out building your own. If you don't want to build your own, you can buy them used. There's quite often a number of these available on the used market, especially the mobile antennas, the mag mounts and things. You'll find plenty of them available. Clean them up, retune them if necessary, and use them. Now there's another option, and that is what I call kit bashing antennas. Now, kit bashing is a term that comes from another one of my hobbies, and that's model railroading, where you take two kits and you combine pieces from them to develop a scale model that's different than the two original ones. You can do the same thing with antennas. One great source of parts are CB antennas, which have plenty of aluminum in them. You can trim them down as mobile antennas, mag mounts, or beams. TV antennas, damaged ham radio antennas, you can get aluminum from all these. Always be on the lookout for aluminum being put out for trash pickup. I found a great pool skimmer that was just one nice giant piece of aluminum that made a really nice vertical dipole just by cutting it, putting a spacer in between, cutting the two ends of the length and feeding it in the middle. It made a great vertical dipole. Lawn furniture, etc. I don't understand why anyone ever throws away aluminum, but if they do and I see it, it gets picked up. Oh, don't forget about those broom handles and things like that. They also make good masts for portable operations, so be on the lookout for those. Construction options for DIY include traditional aluminum tubes and rods, or using wood, bamboo, or PVC booms or supports or covers for your antenna. So you can build a wire antenna such as a J-pole and put it inside of a PVC pipe so that you have one solid piece that you can mount and don't have to worry about it being damaged in the weather. Tape measures can be used for making beams, wire and metal rods. Dipoles, as I mentioned earlier, can be made with traditional wire, but more often they're made with rods or metal. Here's an example using two whip antennas, maybe salvaged from TVs that were being discarded for all I know. Two of them make a dipole, of course, and they can be tilted and moved around. Very similar to the way we did with rabbit ears. So rabbit ears on a central feed point can be adjusted. You can also use copper tape right on a window. So let's say you have a big window and you're up in a high apartment. You could put copper tape right on your window and have your antenna built on your window as either a J-pole or a vertical dipole, and no one would even know it was there. They would just think it would be decorative. You can also build maxons or Yagis for 2 meters by folding the ends back. So they're really dipoles in a way, but they're folded. You can also have folded dipole Yagis, or you can make loops out of these dipoles. The nice thing is dipole lengths are rather short on these frequencies. So 6 meters, the first of the VHF bands, your dipole is going to be 9 foot total. 2 meters, your dipole is going to be less than a little over 3 foot in length. 220, about 2 feet. 70 centimeters, just over a foot. 33 centimeters, under a half a foot. And when you start getting up here, they get really small. I mentioned J-poles a number of times tonight. One of the ones that's typically thought of is the plumber's delight made with copper pipe. And that's where the name comes from, the J-pole being the poles that stick up on it. But you can also make foldable roll-up ones, as we showed earlier. You can also use wire and then mount the wire in PVC. The PVC acts as a radome, basically a cover over that wire antenna. You can also use copper tape elements on a window. Verticals can be a ground plane. They can be a flower pot vertical, which I'll show you in a few minutes here, which is also known as a coaxial vertical. You can also build vertical dipoles. Here's a whole video on building a VHF, UHF vertical dipoles. and again copper tape elements. Here's a simple DIY ground plane using bent metal rods and an SO239 connector. You can build beams for a number of different bands. Here is that satellite beam. There's links here for plans though for 2 meters, 220, 430, 450, 902, 1296. Here's another link for building Yagis. Again, just click on the links for more information on these. Some of them are videos, some of them are slideshows, some of them are websites with great detailed information on them. Here's one. This is called the durable 2 meter 3 element Yagi, and it's built using the 450 ohm feed line here as the driven element, and then we have the reflectors, the directors here. Here's one on how to build tape measure beams. Here's one to build a quad. Now, sometimes you have antenna restrictions in your neighborhood or on your property, and stealth antennas are available. VHF, UHF antennas can look like commercial over-the-air antennas, and the FCC rules say that they have to let you have the ability to receive over-the-air TV. So that's one way around this type of thing. Build your antenna so it looks like, and it will also act like a TV receiving antenna. They just don't realize it works better on the ham bands. You can also paint the antenna to match the color of the roof. A vent antenna looks like a vent pipe. Here's a vent antenna. You can have J-poles disguised as plant supports. Verticals can be flag poles. Radomes, which are covers of plastic, fiberglass, etc., can hide many VHF, UHF antennas. Here's an example of the flower pot antenna. This particular one is for 6 meters, but they can be sized for anything. Basically, we use coax, and then we have the center line, feed of it is the rest of the antenna. PVC base, and you can add some flowers to it. Due to the higher losses at higher frequencies, coax for VHF, UHF should be high quality, low loss, with high quality, properly installed connectors, and a length that's no longer than absolutely needed. Marty put together this little chart. It shows you if you're using RG58, 50 foot of it means your signal you'll lose over half your signal. Whereas if you're using something like LMR40, you're only going to lose about 16% of your signal at that. I also have a chart here that shows 100-foot lengths and the attenuation per 100 foot. You have to be careful with RF safety with VHF, UHF. Unfortunately, VHF is the band that has the most deleterious effects from RF energy that hams have access to. So you need to follow all the rules. And as you can see on this chart, the 30 to 300, which is our VHF range, is the one that has the most RF factors for hazards. So I have 3 resources, including one from the FC, one from New Hams, one from the ARRL, and also a presentation by N6VI Marty that was done on RATPAC on RF exposure in public service events. This one, I would suggest you watch this video. It's really good. It tells you about the differences when you're using a mobile mag mount antenna versus an antenna up on a mast. You get much less exposure to people that are coming around the vehicle with that mast as opposed to the mag mount on the roof. Also, you need to worry about physical safety during antenna installations. Installer falling from heights is one of the biggest problems, but you can also have antennas fall off the roof, or tools or equipment while you're installing it falling on people, both during and after the installation. There's also a shock risk from contact with antenna wires when you're putting up from electrical wires when you're putting up an antenna. Don't hurt yourself. Avoid falls. If you don't climb, try using commercial antenna installers, commercial tree services, roofing contractors, outdoor overhead lighting companies. Any of these can help do some of the overhead work that you do not feel comfortable doing. Also, stay clear of electrical wires or any support that holds up or contains electricity. So we always think about that bare electrical wire, but be worried also about that light pole. Don't use that light pole as a support. You don't know whether the wire that's running up through that light pole is insulated from the metal light pole. And that's actually the only time I've ever gotten shocked in the field, leaning against a light pole and touching my other hand to a basketball upright, pass current through myself. So be aware of anything that contain electricity. Here are some safety resources. The ARRL Field Day Safety Officer Checklist, Channel Master's Safe Installation Procedures for Antennas, Andrew's Antennas Installation Instructions from the On All Bands blog, Antenna Safety Look Before You Install, and one of the first in a series of videos from DX Engineering on an introduction to climbing and antenna installation. Now, I know we've given you a lot of information both tonight and the previous night, and so how do I get started? Well, I put together some simple guidelines picking radios in the 20 to 50 watt range, dual band, dual receive radios in the 150 to 300 range, and a number of different antennas that you can pick out. As you get more experience, you can tweak your setup, but try your hand, and you can also try your hand at DIY antennas. Get an antenna mentor or mentors to help you with this. Some additional resources for you. The Beginner's Guide to VHF and UHF. Marty and I talk about everything about VHF and UHF, including antennas. We also have a Beginner's Guide to VHF and HF, to HF on the guide. So click on this link here, it'll bring you out to the guide. Gives you a list of all the videos. There's over 5 hours of video for both of these and a slideshow to go along with them. Once you start getting done with your local 2-meter operation, think about some more things you can do with your tech license by going to Technician's Life Beyond Local Repeaters. Portable operations, there's a slideshow and a video recording, and that's focused mainly on HF, but it does have a lot of tips for VHF operations in the field. So again, tonight's link is tiny.cc/VHF-ant. You can shoot the QR code, and I will now go ahead and take some questions here. And I'm just going to go through, Barry, I'm going to go through the, is there anything I need to see in the chat?
Nothing, a lot of good ideas, like people that use the golf ball retrievers. Those are extensible. Yeah,
yes.
You can use those as antennas, I would suppose. Let me see what else is there. Use the smaller painter poles, the 6 foot to 8 foot ones, because the 8 foot are too long. Mine was you have to put a good spring on your antenna if you're going to put a trunk mount, because it's a little bit more flexible. If you have
make sure you go to K0BG's website and read about those. He talks a lot about the springs.
Website. And just some very good comments for the people that read through the chat.
So if you have questions, go ahead and put your hand up. We'll try and answer some questions before I have to run tonight.
We're going to get you done in time.
Well, I'm sure there's going to be some questions. There's multiple screens tonight too, so if we don't acknowledge you, just go ahead and speak up, because I may not be able to see you. I'm trying to flip between the different screens here, but if you have a question, just go ahead and unmute and ask your question.
Drop your share so we can see the gallery.
Yeah, well, I'm seeing the gallery now. I have that on the other monitor.
We see you. Okay, here we go.
So questions, comments, suggestions, complaints.
One of the things some of the people mentioned in the chat was when you have your presenter mode on, we spotlight you and you were blocking some of the slides, but the slide presentations you go to see won't have you in the way, correct?
That is correct. And also the slideshow is always being updated too. So if you go to that link that I showed earlier for this tiny.cc/VHF-ant, that will get you the most current slideshow all times. And I'll put that up here real quick just for a second. Again, I'll share the screen. You can shoot the QR code and get access to that.
I have 2 suggestions.
Yes, go right ahead.
Well, one of them is on the extendable poles. Sometimes the twist locks are not terribly secure, and it can easily be fixed with a hose clamp.
Yes, Let me mention one other thing too. One of the problems is they are too good. So I would suggest whenever you're bringing any type of mask like that, make sure you pack rubber gloves, especially the Playtex washing gloves that you use for washing sink. You'd be surprised how much more leverage you get when you have rubber gloves to be able to twist those and loosen them up when they get stuck. Yeah, your second one item?
Yeah, well, it had to do with your antenna safety. I'm blessed by having some really tall Douglas firs on the property boundaries. And I'm too old to climb, of course, probably never wanted to climb. So when I had tree trimmers out the last time to do the wind sailing, cleaning up the broken branches up high,
Yes.
I had them put up flag halyards
Oh,
with pulley at the top and a continuous loop of rope. And now I can raise and lower each end of the wire antenna from the ground quite safely.
that's good. Other questions?
Katie 7, ISA.
We have
Yep.
two hands up also.
Okay, go ahead.
Bonnie, I'll go ahead.
I was just typing it in the chat, but I have a new car that has one of those extended sunroofs in it.
Yes.
So I don't have a lot of roof, if you will, and I have a mag mount, a small mag mount, VHF, UHF antenna on it. And I didn't know if you had mentioned earlier something about, possibly a half wave antenna if you didn't have a lot of surface area. Is that the ideal for what I've got, or?
That's probably going to be a better bet, especially if you have a really big sunroof. And you might want to think about doing something like a hatch mount, so you move it away from that to over some more metal. The whole thing is most of these antennas are designed for some counterpoise underneath them. And I know what you're talking about with those extended sunroofs. There's really not much metal there.
Okay, but a half wave would work,
Yeah,
right?
half wave would probably work better.
Okay, thank you.
You're welcome.
All right, Tom, you got your hand up?
Yes, sir, I do. I just wanted, apropos of the third person back, when you put up halyards, you might look at a thing, you'll have to Google it because we don't have time, but you might look at a thing called a pull down rappel anchor. And it's in all the mountaineering sites and so forth. What it gives you is a way to retrieve the whole apparatus to the ground without giving up your anchor at all. You can pull it right back into position. It's a little tedious to do, but it works. So if you've got a jamming pulley or something up there that you've got to get back down on the ground, but you don't want to call the tree folks that Anthony was referring to earlier, well, then you use the pull down rappel anchor and then slide it right back up there using the reverse of that. So for what it's worth, your mileage will vary. And I wanted to mention to everybody, because we do a lot of public service things here that involved the Washington, D.C. area. The quickest way to get in an argument with the United States Park Police is to do anything, and I mean anything, including drive a tent stake that they see as damaging the grass. You cannot put in tent anchors on United States Park Service regulated land. The park police will go nuts. That's all I have for you.
Wow. That's government for you. Okay, Paul, you got your hand up?
Yeah, I put in a reference for one of our local experts on RF safety. There's a link in the chat. If you go to page 31, they've already pre-figured out what would be safe if you're going to put up like a J-pole for 2 meter. I think if you have it up at the bottom up at least 15 feet, it's like page 31. It shows that they've already prefigured the safety for that. I think it's a good thing. 31 right there. Yeah, that.
I will add that to the slideshow afterward.
Okay, I might comment there, Anthony, when you share your desktop and you're sharing yourself within the desktop, it covers up important information.
Okay, I'll make sure I don't have that when it lit up again.
Anybody else? Hands, feet?
Looks like we're right on time.
Yeah.
Well,
Did you really just say that?
two quick things. Make sure you take a look at the session introduction for this series, because we talked about that last time. It's also available at the RATPAC site. So this session right here, first steps in amateur radio, we talked about that in the last presentation, but it's available separately. So when you go to YouTube or the RATPAC site, make sure you take a look at this. It talks about the whole series, and we'll be back with more in the upcoming weeks here for first steps in communication. So thank you, everyone. I'm going to have to say 73. I'm going to go ahead and leave, but Dan, you can shut the meeting down whenever you're ready.
Okie dokie, Anthony. Take care. Have a good meeting. And thanks for everybody that joined us tonight. Is there anything else? Anybody have any more comments here?
I have a question for Tom W3DH. Tom, you mentioned a pull down rappel anchor that could solve problems that you can't get to. Could you explain that again? Pardon me. I didn't catch it all, nor do I understand it.
It's a way to anchor a rappel in mountaineering and fire and rescue, where the webbing you use has two rings on the end of it, and one is smaller than the other. So the small ring will pass through the large ring, but not vice versa. So if you just look it up on a mountaineering website, Google it, you'll see how to use that so that you have it put up there the first time. And then, or you can even put it up there with the potato guns and the slingshots and the tree throwers and any of that. Once you have it up there the first time, if you need the whole assembly back down, let's say your halyard pulley is misbehaving. Sure, you could bring any part of the halyard back down, but you can't bring the halyard pulley back down. Well, with this belay, you can actually feed the halyard pulley back down using the anchor line that that went up there with the first thing in the first place. Because you take one thing to haul a halyard up there, and it stays, you tie it off someplace, and you've got the halyard hanging down from the pulley. But you could use the pulley to pull down the belay, just like climbers do after they're down. They're not going to climb up to get that damn anchor down, and yet they're fairly valuable. So they have a means of pulling them back down when they want to leave. So you look it up, any mountaineering site, a few fire and rescue sites cover it. And it's not at all tricky when you see the illustration, but it's a way to save equipment and also maintain the pulley. After an ice storm or anything like that, things can get shabby. And come spring, you know, your anchor could use a good examination anyway because of the ice and so forth that may have been through the winter. This allows you to bring it down and send it right back up as soon as you're through with your maintenance.
And what's this
Thank you. Thank you very much.
And what's this called, Tom?
It's called a pull down anchor belay, or pull down belay anchor would probably get you better results. And
That's very good. A lot of us have that problem with our towers we don't want to climb too. Okay, are there any more comments, questions, or answers out there?
ISA.
ISA's got it.
When I hear using the painter poles, I do have a couple of those. They're 3 8-foot sections, but somebody told me a better idea, which is there's a pole that's I believe it's used for cleaning windows. I found it near the light bulbs, and it has 4 6-foot sections. And since that's closer to my height, that makes it easier to get those up and down. It was about $54 for that one. The painter's pole was probably only 60% of that, but it's worth it for the 6-foot sections, and it's triangular in shape.
Interesting. Thank you. Great device. Anybody else?
the reason it's triangular is applying torque to it when using the bulb changers that get put on the top of it, because you have to be able to get that blasted Edison base of the bulb to come loose from the Edison socket of the fixture. And sometimes that takes a bit of pressure and force. So triangular shape makes it possible for you to twist it harder.
What? You break the bulb like I do?
Well, the other thing you'll see if you look hard enough in a janitorial supply house is the adapter for the pole that's made for taking the broken Edison base out of the Edison socket when it's just too frozen and it busts on you.
Okay, well, thank you very much, Tom and everybody. Anybody else got anything out there?